Welcome all. In last lecture we have studied adder, subtractor and BCD adder using 4-bit binary adder. Today we are going to study the code converters. In this we are going to discuss two code converters, that is binary to gray code converter and gray to binary code converter. We already know how to convert a binary to gray and a gray to binary number. We have studied this conversion in the first chapter. This is the block diagram of binary to gray code converter for 4 bits input. These are the binary inputs, that is are of size 4 bits, that is from B0 to B3, and these are the outputs, 4-bit outputs, that is from G0 to G3. These are the inputs and these are the outputs. Depending on this we have to make a truth table which consists of 4 inputs and 4 outputs. This is the truth table. The binary inputs are B3, B2, B1, B0, and gray code outputs are G3, G2, G1, G0. The sequence for binary input, as there are 4 inputs, the total number of combinations are 16 from 0 to 15 in sequence, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the sequence for binary numbers. We already know how to convert binary to gray code, so I will take the 2-3 examples, 2-3 input combinations from these binary inputs, and how they are converted into gray code I will explain now. We already studied this, but for the purpose of revision I will discuss 2-3 binary inputs. First binary input is 0 0 0 0. We write the MSB 0 as it is, and we do circular addition. 0 plus 0 will give you 0, this 0 plus 0 will give you 0, and this 0 plus 0 will give you 0. So for 0 0 0 0 the gray code is 0 0 0 0. Now if we take this input combination, that is 0 1 0 1, this is the binary input. Now we will convert it into gray. 0 to 0 0, 0 plus 1, 1, 1 plus 0 1, and 0 plus 1 1. This is the gray sequence, that is 0 triple 1. This is how the binary to gray code conversion can be done. So you can check for all the remaining input combinations how the binary numbers are converted into gray numbers or gray code. Now we are going to, after the completion of truth table, we are going to find out the equations of output variables from which we can draw the logic diagram. The output variables are G3, G2, G1, G0. So we will find all the 4 equations of output gray code. This is again the truth table is taken as it is. Now we are going to use a K-map for finding equations. First we will see how to find the equation of a G3 output variable. This is the K-map. As there are 4 inputs, the 4 variable K-map is used. In the vertically B3, B2 variables are taken, horizontally B1, B0 variables are taken. The entries of G3 output are made available onto the K-map. The first 8 outputs are 0 0 0 0 0 and 0 0 0 0. After all the 8 outputs are 1 1 1 1 1 1 1 1 1. This is how the entries are made for the G3. Now here, after this entry, we are going to find octet, chord or pair. Here a octet is possible. For that we will get the term as a B3. So the output equation for G3 will be B3. After that we will find the output equation for G2 variable. Again we take a 4 variable K-map. The entries of this G2 column, we are going to make entries onto the K-map. The first 4 outputs are 0, so 0 0 0 0. After that 8 outputs are 1 1 1 1 1 1 1 1 1, and last outputs are 4 0 0 0 0 0. After this we are going to find any octet is possible, chord is possible, or pair is possible. Now here in this case octet is not possible, so 4 chords are possible here. Sorry, 2 chords, this one and this one. So for this chord we will get the equation as B3 bar B2, and for this chord we will get the equation as B3 B2 bar. Already we know how to find these terms for with respect to the chord, pair or octet. In the same way these terms are formed over here. So the equation for G2 will be B3 bar, here it is a bar, B3 bar B2 and B3 B2 bar. So this equation seems like a equation of XOR gate. So in short, the equation for G2 is written as B3 XOR B2. After this we will find the equation for G1 variable. The entries of G1 column are made available onto this K-map. After the making entries, again we are going to find out the octet, chord or pair. Here no octet is possible, 2 chords are possible, this one and this is second chord. So for this chord we get the equation as the term as B3 B2 bar, and for this chord we get term as B2 bar B1. So for the G1 variable we get the equation as B2 B1 bar and B2 bar B1. Again this equation seems like a equation of XOR gate, so G1 equation is written as B2 XOR B1. After that we are going to find the equation for G0 variable. For G0 variable, again the entries of G0 column are made available onto this K-map. After the entry, again we are going to find octet, chord or pair. Octet is not possible over here, 2 chords are possible, this is one and this is second. For this group we get the term as B1 bar B0, and for this group we get the term as B1 B0 bar. So for G0 we get the equation as B1 bar B0 and B1 B0 bar. Again this equation also seems like a equation of XOR gate, so the G0 equation is written as B1 XOR B0. We find out the 4 equations: G3 equal to B3, G2 equal to B3 XOR B2, G1 equal to B2 XOR B1, and G0 equal to B1 XOR B0. From these 4 equations we can draw a logic diagram which consists of 4 inputs B3, B2, B1, B0. These are the binary inputs. For G3 we get a B3 equation as it is, so here no gate is required. For G2 one XOR gate is required, to which B3 and B2 variables are connected as input, so that we can get for G2 B3 XOR B2. For G1 B2 and B1 variables are connected as an input, to this XOR gate. So we will get the G1 equal to B2 XOR B1, and for G0, B1 and B0 inputs are connected, so we get B1 XOR B0 expression for G0. This is how we can design a binary to gray code converter for 4 bits binary input. Next we will study the gray to binary code converter for 4 bits. This is the block diagram, which consists of gray input of 4 bit and having binary output of 4 bit. The gray inputs are G3, G2, G1, G0, and binary outputs are B3, B2, B1, B0. After this, we can have a truth table which consists of gray code input and binary output. For this, we have to know a gray code sequence for 4-bit gray code, which starts, the sequence is 0 1 0 1 3 2 6 7 5 4 12 13 15 14 10 11 9 and 8. This is the sequence of gray code for 4-bit gray code. In this sequence, we have to write the gray code first. From these gray codes, we already know how to convert a gray into the binary number. I will tell 2 examples of gray to binary conversion from this table. So first I will take this one. The gray code is 0011. I will convert it into binary 0 to the 0. Here we will do a diagonal addition, 0 plus 0 0, again this 0 plus 1 1, again this 1 plus 1 0. If any carry is generated, we are going to ignore that. So for 0011 we get 0010 as a binary number. Again I will take another example. This one, the gray code is 1100. I will convert this into binary. This 1 plus 1 0 0 plus 0 0 plus 0 0. So the binary number is 1000. For this is how we can convert a gray code into the binary code. You can check for all other input combinations. As there are 4-bit input gray code, 16 possible combinations are available, so you can check for the remaining. So from this, again we are going to find out the output equations of B3, B2, B1, B0. For B3, we are going to make the entries of this B3 column onto the K-map. Again, as there are 4 inputs, so we are going to use a 4-variable K-map. Vertically G3, G2 variables are taken, horizontally G1, G0 variables are taken. After making all the entries, we get this code, which is having the term G3. So for B3 we will get a G3 equation. For B2, we are going to make entries of this B2 column onto the K-map. After entry, we are going to get this equation. In this, we have got 2 codes. For this, the term is G3 bar G2. For this, the term is G3 G2 bar. So for B2, we get equation as G3 bar G2 and G3 G2 bar. So this equation also seems like a XOR gate equation. So the B2 equation, for B2 the equation will be G3 XOR G2. Again for B1, we are going to make the entries for this B1 column. After entry, the K-map will look like this. Here again no quad and no octet is possible. There are 4 pairs. For each pair the terms are written over here. 4 product terms written as it is. From these 4 terms now this equation is not reduced, the equations is rearranged so that we can get a simplified expression for B1. Here from this term and from this term G1 variable is taken as a common, so the equation will look like this, and from this G1 variable is taken common, so that the equation look like this. Here it is G1 bar is taken and here G1 is taken as a common. So again this equation is like a XOR and this equation is like a XNOR. So written as it is G1 bar into bracket G3 XOR G2 G1 into G3 XNOR G2. Again G3 XOR for X is put as a G3 XOR G2. So the equation will become as G1 bar X plus G1 X bar, which is again look like a expression for XOR gate. So equation is G1 XOR X. The value of X is G3 XOR G2. We put that value in this equation, we can get G1 XOR G3 XOR G2. So for B1 we can have the equation as G1 XOR G2 XOR G3. Again for last B0 term we are going to make entries of B0 onto the K-map. After entries the K-map will look like this. Here we will not find any chord, octet or pair, so we are going to write individual terms for each one. These are the individual terms for each one and we are going to add them. So we will get the equation for B0 like this. Here again we are going to rearrange the terms so that we can get the simplified equation of B0, which will help us for drawing the logical diagram of gray to binary code converter. Again here a G1 bar, G0 bar terms are taken common from this and from this. This is our first term. After that G1 bar, G0 variables are taken common from this and from this, we get this term. After that G1, G0 terms taken common from this and from this, we get the term like this. After that G1, G0 bar variable is taken common, G1, G0 bar, and here it is G1, G0 bar, which look like this. After this the bracket contains expression of XOR and XNOR gates, so those are written, and after that we will get the expression like this. Again here now here from this and from this G3 XOR G2 is taken common, we will get the term like this. After that from this and from this G3 XOR G2 taken common, we will get the equation like this. After this we can put this as a XNOR gate expression and this as a XOR gate expression. Now from this equation we put G3 XOR G2 as a X and G1 XOR G0 as a Y. So after putting X and Y we get B0 equal to XY bar plus X bar Y, which is again expression for XOR gate. After this we are going to put values of X and Y, we get the equation like this, G3 XOR G2 XOR G1 XOR G0. So finally we get the B0 as G3 XOR G2 XOR G1 XOR G0. This is how we have simplified the expression. We have not reduced the expression, we have rearranged the terms so that we can get the simplified expression, by which we can draw a simplified logical diagram for the given converter. So after this we get 4 equations of B3, B2, B1, B0. From this we can draw the logic diagram like this, which is having gray input G3, G2, G1, G0 and binary output B3, B2, B1, B0. This is how we can design a gray to binary code converter for 4 bits. Thank you.